Hi, my name is Anna Teper, and this is my midterm debriefing for ETTC class at the University of Texas. I'm a graduate student of Masters of Math program, and this class is a requirement as an instructional course. This is my second master's. My first is in secondary education. For this project, I chose to help my students increase their park assessment scores by the average of 5 percentage points. I will describe what is a park assessment, how I'm planning on achieving that goal in subsequent slides. Um, my project consists of several practice sessions for the park assessments and also additional instructions that is aligned with our the school's curriculum for algebra classes. What is PARC? PARC is a partnership association for readiness for college and career. It consists of two summative tests. One is performance-based assessment, which is administered around a midterm of a year or slightly after a midterm of a year, and the end of the year assessment. Now, about 75% of schools or districts that are involved in that partnership administer the performance-based assessment, and about 90% of those administer the end of the year assessment, which usually falls into mid or end of April of a school year. Each of those tests has a calculator and non-calculator components, and they, in terms of math portion, they measure critical thinking skills, problem-solving skills, innovation in solving problems. There is a very little of multiple choice component to each of those tests, and a big emphasis is on free response, open-ended questions, essay type of questions when students have to list a sequence of steps they would take to solve a problem that was given on the assignment. What is PARC 2, and also why? With the Common Core that was introduced to many states, the standards became more rigorous. They're probably the most simple way to describe what is Common Core in math curriculum is to narrow down the path of how many standards are we teaching per given term or per given time frame, but way more in depth. So before, if we had several, for example, functions, comparison of functions in semester one, with Common Core, we literally look at only one function entire semester. It's a linear function, but we study it in terms of linear function, the behavior of the function, the graph, the interpretation of the graph, the relationship of one function to another in terms of systems of equations. Then we extend a little bit to inequalities. So again, a whole semester is dedicated to a very deep study, rigorous study of a one basically one function, one standard. And we needed more rigorous assessments for those standards. And our prior tests that have been widely administered and accepted by states, by districts, and also by universities as a measurement of student skills have been, most based on most times measuring only lower level skills. Multiple choice questions, as anyone probably would agree, are easier to take, easier to pass than open-ended questions, essay type of questions. And we would like to steer from that to be able to really tell what students know and what students are capable of doing, capable of achieving after they move on from, our teaching. Partnership for Assessment and Readiness for College and Careers has been introduced to many states. As this map show, roughly about 40% of all states adopted it at some point. They had either governing or participating rights. Governing states had some flexibility in terms of how they're going to use the assessment and what to what capacity. Participating states just adopt those standards, those the test itself. At this point, there's only 9 states left. They're still administering park assessment to their students. Illinois is one of them. There's several reasons behind this trend. Just to mention a few, one would be the technological issues, challenges many school districts have to change, have to invest heavily in technology, in broadband, and this poses financial challenges. Another cause could be that colleges, universities still have not really been open to accepting park test scores as a measurement of what students have achieved in their high school education and what can do a prediction of their future achievements in college and beyond. Also, on average, park scores are lower than ACT scores, for example, given the difference of the rigor of questioning and ACT being multiple choice question and park, of course, being not. The difference of levels is could be an argument against park tests for some parents, stakeholders in the district. Again, there's probably more complex decision making behind some of the states dropping out of the partnership. Nevertheless, the state I teach at is still in. Here's an example of a park question. In algebra, park measures each grade level up to high school, and high school measures algebra, geometry, and algebra 2. This algebra question has a visual representation. There is a word problem preceding the visual representations. The student needs to read the problem, look at the table, and being able to interpret the table, that there was a scenario of a teacher having 4 classes and offering to the students in each class 3 choices of a field trip, and then recording those answers. And the students are required to insert 2 parts, part A and part B. And again, it's not a one-step question. Part A asks the students to determine the percent of students in each class who chose the museum as their choice. That requires students to take the ratio of the students who chose that destination over the total number of students. Then they have to compare those values, compare the percentages. Again, the ratio itself, it will be a decimal. Students have to change it. I mean, it's not really necessary for them to change it into percentage, but they might be confused why they don't see percentage sign if they are missing that concept, that skill. Then they have to rearrange those blocks representing each class in order from greatest to least. If they rush through the question and they put it from least to greatest, again, this would be incorrect answer. Part B is a completely free response. Students have no guidance into what value should, at least it's a ballpark of the answer, as it often happens with with multiple choices. And again, as you can see, the complexity of the problems requires several steps, several reasoning skills, and it could pose a challenge for some of the students. A little bit about the high school I work at. Is a high school is located in Romeoville. It's a suburb west south suburb of Chicago. It serves grades 9 through 12, and just based on the previous ACT scores, and it earned 4 out of 10 stars. It's just the visual of where we are located. From Chicago, just 1 hour drive away. We really, as teachers and students, we enjoy the proximity of that beautiful and vibrant city of Chicago, yet still enough distance from the city to enjoy the suburbs. Just a visual bar chart based on the previous years, not including 2015, of PSAE scores. These would be the ACT scores for the high school. Math and reading, as we can see, the reading is steadily growing, while there have been some issues, some fluctuations with math scores. In between 2011-12, there have been a slight increase and then a little bigger decrease, and then again slight increase from 2013 to 2014. There's been adaptation of, again, Common Core, change in curriculum. All those factors affect the scores, plus new cohort of students coming from different feeder schools has its effect on the averages as well. This year is the last year where our juniors are taking the officially ACT test because they were not ready to be, they haven't transitioned from PARCC testing when they were middle schoolers. Therefore, we were still, as a district, decided to pay for the ACT scores to allow them that jump forward to their college careers. My instructional solution has been divided into 3 objectives. The first one was test-taking skills. Some students still need to study those skills, are not aware of those strategies that they could use during test, before the test, in, day before, the morning before, weeks before, that would increase their understanding, increase their energy levels, increase their confidence in terms of being successful. We have been reading many word problems in classes, focusing on the keywords, looking for the question, what is the question asking us, so we can go back to the word problem and focus on those key parts, key elements that would help us solve that problem faster, more efficiently. The efficiency is, although PARCC test is technically so far has been allowed extended time for some students, unlike ACT, which only provides 60 seconds per question. Of course, this is not a one question time problem. It doesn't move on because it's not a computer based, but nevertheless, we divide all questions. We all the entire time by the equal number of questions. We only have 60 seconds. We have more time here for a PARCC. Nevertheless, of course, the time is limited. Therefore, students still need to work on their efficiency in reading and understanding material. Some of the strategies are listed here. Always encourage practice, making students more efficient in reading the material, in reading directions, looking for what is being asked. If there's several components to the question, answer all of them. Is there a unit that needs to be included? Does the answer make sense? Also, am I showing full work? Because if I don't, then there is no way of checking if my reasoning was correct. And up to the last point, if there has been a mistake at the last step, it is impossible to trace it back, to double check. A last step, as I already mentioned, just making sure the question makes sense. Sometimes students would get a number that is a negative value for a quantity that cannot have a negative number. For example, distance jumped. Of course, when we graph a function, there's always those negative values that are outside of our feasible interval. But when we want to interpret that, we need to make sure we're understanding the concept, the background information as well. My second objective was specific standards and skills that were aligned with curriculum for algebra classes in our school district. Those are operations on polynomials, adding, subtracting, multiplying, dividing. By the division, we mean factoring polynomials, which does tie to quadratic functions, which we studied and analyzed in the first quarter of this semester, second semester. Linear functions, I've said before, were a focus of the first semester, but now we're tying it in. We're looking at the graphs, we're looking at the characteristics, the vertex, the behavior, the zeros, the solutions. that we can look at different representations of functions, equations, graphs, tables of values, word problems, expressions, calculating the average rate of change, looking at the intervals as the value of y's are increasing as x moves to positive infinity. When does that y reach its maximum? And if we have a word problem, what does the maximum mean? Is it talking about the height? Is it talking about the speed? Is it talking about the time? A lot of different perspectives we can look from at that graph, at that function, looking at the bigger picture other than just the numbers, just the lines. We've also done linear inequalities and systems of inequalities. Since it was the material was covered in semester 1, I used some of like online activities to help students refresh their memory. As we know, educators, what was taught a couple months ago does not necessarily get retained in our, among our students. Here's an example of a multiplication of two binomials. This was an example given to students as part of their notes, color coding, showing the steps. Students have a flexibility of choosing which terms they want to multiply first, second, third, and the last. This is just an example. Again, students can manipulate a little bit with those terms and combine like terms at the end and arrive at the same answer. But by allowing them a little flexibility, they feel like they own their method. They don't have to do it the same way the teacher's doing or the neighbor's doing. As long as they're following the order of operations, they'll be successful. Another example shows opposite operation to multiplication of polynomials. This is a division of polynomials, but not by polynomial, but polynomial by a greatest common factor. And this method is called factoring by grouping. Well, nevertheless, I'm sure not everybody's interested in math, but it shows just steps, shows the reasoning behind it, because we have visual description and we have detailed verbal, written description. Of course, I provide verbal part as well as I teach, as I show the instruction. Students then they can use those notes to throughout their guided practice and then individual practice. And the third objective deals with standards for mathematical practices. There are 8 of them. They're aligned, or actually they were attached to Common Core standards for math. I'm going to describe them briefly in the next slide. Here we're just divided in terms of my sequencing for planning and keeping up with the schedule. My objective was to have students reflect on those standards as a journal writing. I will describe a little more in detail about the concerns I have with this objective. But for now, there are 8 of those practices that we as adults, we as students, we as teachers, we as members of society use probably daily. First one is making sense of problems and persevering in solving them. We see an obstacle, we try to figure out the best way to overcome that obstacle. Same goes with a mathematical problem. Then we need to use abstract reasoning. We need to try to put some quantities into numbers, or opposite, we look at the numbers and try to make a broader picture out of those. Then we construct viable arguments. That's a third practice. When we have an argument with a coworker, with a family member, with another student, trying to agree or disagree politely, respectfully, diplomatically, using reasoning, using our knowledge, using listening skills. I disagree with you, and this is why. I'm going to give you a counterexample. Another person was going to listen. Based on your counterexample, going to respond. So I encourage those conversations in class, in my classes, sometimes as a group, sometimes as a whole class discussion. Students are doing those practices. They're following them. They're using them. They're model with mathematics. Some students will draw a number line as it shows a number. For other students will just write an equation. Some other students will draw little circles like a Venn diagram, or perhaps some blocks as it shows in number 5. And when we can use tools appropriately, as some manipulatives, some maybe a calculator, maybe protractor. These are the tools that we encourage our students to use. We use them as well in our own life. Next one is attending to precision, including units in our answers, being able to convert the units. We travel abroad, we need to be able to convert currency. If we don't know how to do it, we lose some precision points there, decimal points, it's going to cost us, right? So students are learning those skills. And then 7 and 8, looking for structure, looking for repeated reasoning, some regularity that they can take, analyze, and apply to future problems. And as I already said, most of them are done daily in math classes. I just believe the students are not really aware of what they're doing in it. If they're not aware of, they cannot reflect on it. They cannot build um, stronger skills and stronger understanding of math processes. And I wanted to include this objective as a part of my instruction this semester. It hasn't been really all that successful for several reasons. Where one is going to come up in a second. The curriculum is it's structured for our school. We have teams, algebra teams, geometry, algebra 2 teams. Each team sets up its own calendar. We follow it pretty strictly, and there's not much room for flexibility or changing daily instruction. I do have a flexibility of assigning different assignments to students. However, there is a major school-wide problem: students' lack of completing homework assignments. So if I assign a journal writing for students I have an average of about 75 students right now, my freshman classes. Probably, I would say maybe less than 1/3 does those assignments. It doesn't give me a big picture of where all the entire cohort in terms of moving forward with my goal for this project. It just hasn't been as successful as I was hoping it would be. And the last part I've already mentioned: difficulty and complexity of the PARCC questions. Students throughout the practice have been exhibiting some frustration, some unhappiness with the way the questions were posed and asked. And that, of course, results with our curriculum for algebra is not necessarily PARCC aligned. It's aligned with Common Core, but those questions are not at the same rigor level as the PARCC questions themselves. My completion, I projected to be 90% on time, correct. Students are taking the performance-based test in a couple weeks, and then a month from then it's going to be the end of the year assessment. The journal writing and the reflection, I was planning for mathematical practices. Perhaps I will still have a little time. Maybe there'll be some time for reflection after they take the assessment and still before the project is completed. My possible concerns are that some of the freshmen might not be taking the PARCC seriously. Again, it stems from colleges not accepting PARCC results yet. A lot of stakeholders, parents, school boards members are advocating against it. So for freshmen, there's really no motivation to keep getting better at taking the PARCC test, because in a couple years when they're juniors, it might not be there at all. We might go back to ACT testing or perhaps SAT testing, or there'll be some other standardized tests that should be widely administered. We at this point don't know, and I cannot input anything valuable, and cannot assure my students that this will be or will not be the case in 2 years. During the test, as I've seen during practice testing, some students are shutting down when they have a free response question and they're stuck. They don't know where to go, what to put. They either put some random number, or they'll just leave it blank without really trying to figure things out. Um, as with any free response, there's always room for partial credit. Uh, there is, at this point, park test is it's still graded by hand, especially the open-ended questions. So there is a possibility of students earning some credits, some points just for showing some work, showing a few steps, even though the answer might not be, fully there or correct. But I know many students are mentally might not be there. Also, students choosing the easiest question. It could be a little tricky questions where students seeing a number that pops out of the equation, out of the graph, that is there to sort of lure them to pick that answer without thinking a little deeper or double checking if this is really what the problem is asking. Is this really the right solution? Does it really make sense for that problem? So these are the possible concerns that I foresee. And as of now, I would like to thank you for watching, listening, and reflecting. For me, definitely, it's been a very valuable experience when I have looked at what I've done, completed so far, where I am, and where I still need to go in terms of being successful in this class. Thank you.